Sure the volume is on. And I may begin a few minutes early and end a few minutes early after I make sure everything is okay. Okay. Begin a few minutes early. Seems like it's okay. So I went ahead and copied a couple of problems here. I think I'll delay on this one and do this one and then this one, but let's see what we can get done. So if we look at this thing, it says member AB. Why is it? Let's go to, you know what? Let me try this. I'm using a different pen. So hopefully, let's see. I guess that's good enough. Oh, well, I don't want to use this pen. This pen doesn't have the, let's try the other pen. Yeah, it's a little darker. Okay, so we start with the velocities. Okay, this will tell you this velocity up here, because if you ignore the accelerations for a minute and you're just focused on the velocities, you'll realize that's the case. What I'm going to do now is I believe I can go back to the book and find this problem. And I believe it's that one. I am going to use this and oh, okay, and I should have used the pen instead of the mouse, but that's good enough. Move back over. I'm going to drop it right there. It's too big, so I'm going to shrink it down. I'll even put it under here so that we can look at it. If you look at this thing, okay, I'm just going through it in an instant center kind of way. So you know this velocity is going to probably go in this direction. So therefore, because of this link, this velocity is known. And I can go ahead and put it down. Velocity of B is equal to omega times the R. And I'm just putting a dark thing there. The R in this case is 2. The omega in this case is 4. Velocity of B is 2 times 4 is 8. Now, if I go down to this picture, it's as if this link no longer existed. And I know this velocity is 8. And I know this velocity is something. Do not know what it is. So now, if I decided to, there we go. Use my rulers. Produce a perpendicular the best I can do. Okay, here's my perpendicular there. So it's pretty apparent that these two, okay, reminder, what am I doing here? Here, let's use that. Here, we'll use this color. So this is 90 degrees. 90, oops, sorry. Here, 90 degrees in this way. Draw a perpendicular to the known direction of the velocities, and what you get is a location where they cross that is the instant center. It can almost be viewed as though this triangle which we'll just always call it a triangle, is a rigid body which is moving this way. Why do I know it's moving this way? Because this is moving at 8. I know that. So what is omega? This time we're going to designate it BC. Okay, with that, I'm going to go and fix myself here. This should be here. Make it AB for the omega of that link. R from AB to the instant center, which in this case the instant center is the always center of rotation, point A. And so that was 4 and this was 2. So now that I've corrected myself as being okay, velocity B exists on both links. Therefore, it's still 8, and it is the omega of BC times the distance from B, to the instant center. Now I got to deal with some geometry. Okay, so not that bad, not that good, but still there was a okay, I believe I missed it. I was not, in other words, I did not carry this half down in the picture, so for that I'm kind of remiss. But if we look at this now, let's really kind of see what we can do about going along through here. Okay, this one might be a little bit harder for me, especially since I haven't had caffeine, and this is a live lecture, so I'm going to take a break for about 1 minute, drink caffeine, or about 15 seconds. And I'm going to go back to it. So if you're picking up the stream right now, I've kind of started it a few minutes early because I've got a short day ahead of me due to some meetings. But I know this is all recorded, so it's all good. So here we go. How do we deal with this geometry? I'm going to go ahead and recognize a couple things, or not recognize per se, but here, let's see. Yeah, I'll just use that. Okay. So whatever this angle is the same as that angle. Oh shoot. Looks like that's going to be tied. Okay, but I could do this. Okay. So, I hate to do this, so I'm going to call this angle alpha. Now, I know this angle is going to be 90. I know if I draw this off to here, okay, so I have a vertical line that goes this way. My brain is not functioning particularly great right now. This is not going to get you much. Hang on. This is not going to get you much. So, let's see if I can come up with a different approach. And that different approach might be interesting and a little bit on the lazy side. This is 2, this is a half, therefore I can get that angle. So why don't I just go do that? So if I had a triangle that was that, and then, oh, I can't copy it. Can I not copy it? Well, here, I'll just do it up here then. Here's a triangle. Well, okay, let's try it again. This is 2, this is 1/2, this is whatever. So, in essence, I like to go across and figure out the 2 squared plus a half squared, and I don't have okay. I'm going to find this 2 different ways. Square root of 2 squared, which is 4, plus 0.5 squared, 2.0616. So 2.0616, I believe. I may be wrong. Yeah. So now if I want to know this angle, I could do I don't know if I want to do it that way, but and then what I'm going to do is check it using the sine of so let me do that real quick. You know what? I think I'll just put this in as A, the angle. No, just call it D for the distance, the hypotenuse there. I should have called it H, but that way I'll have all the digits. So this tells me 75. 0.964. It looks reasonable. Let's go back now, just as a check. 70.5.964. Now, some people might have wanted to come in and did the arctangent, and 2/2, which that, well, I'll do it that way. Divided by 0.5, and you get the same amount either way. So either way you get it, you're going to get this for the angle. Now, that's the angle that sits right here. And 964. That didn't really get you anywhere. In that, you need to know this, which, believe it or not, is nothing more than 90 minus alpha. So I think at this particular point, if I can get rid of those, I got that, right? Since this is, let's go ahead and find alpha. I mean, I've been kind of delaying doing that, but I'm going to go ahead and do that. So if this were alpha, this would be inverse cosine of the 3 and the 5. I didn't want to do this, but I guess that was maybe why I was doing things that way. I was trying to avoid, because I don't like doing this. 53.13. Okay, so if this is 53.13, then this is 90 minus that, or 36.87. Didn't want to have to do that, but okay. So if this is 36.87 between here and here, I know this is 90. So this will be 90 here. Oh, shoot. Okay. 90 minus 36.87, which sends me back to 53. Now, here's the part where talent is embedded. It depends on how your brain is operating that time. If I look at this, I should have known that, but because of an interesting fact, and I'm going to hack it up and then do it. This line is perpendicular to that line, and this line is perpendicular to that line. So those two facts alone would have meant that I could just copy the angle from right here to right there. Other people who are watching this probably saw that, but hey, that's okay. So what you have is you have a triangle now, and I'm going to try my best to duplicate it here. It looks like this, in which this angle is 53 plus 75. Okay, so what I'll do is I'll just 53.13 plus, there it is, 75.964, 129.09. I know that the distance here, okay, I know it because it was not given to me, but I know the distance here now. .0616. Okay, now what else do I know? I need to know one other angle somewhere. So let's see if there's a way for me to find that. Now, I have a bunch of junk here, and I have to apologize about that, but let's take a look at something here. And as we stare at this triangle, remember, this triangle is mimicking this triangle. So knowing that, then I can start operating off of some information on this triangle. Mainly, this is 90. This is the other angle. So if that's the case, then this angle here, I mean, I can use the cosine and sine, but I know that's 90, so I can just take 90 minus 75.964, and it'll give me 14.036. Now, that triangle that sits, that angle between here and here is the same thing that sits right here. And I already forgot, 0.036. So now that tells me right off I can find this one. This one will be, and 180 minus 129.09 minus 14.036. Okay. It becomes 36.874. Now, I got enough. Okay, now, you have to remember, in your triangle, what you need, you need, and here's what I'll do. I need this distance, and then I need this distance. Why? Because this is my triangle. This is my, in other words, this is my rigid body rotating triangle here, in which I am rotating about that spot. So if I want to know the velocities or the rotation, I need to know this distance and I need to know that distance. Well, that's pretty convenient because here, you look at this thing and you say, I'll call it distance 1. We'll call this distance 2. Distance 1 over the sine of 129.09 equals to the distance 2 over the sine. Okay, you're looking at the opposing angle from the side, 14.036 equals to distance 2.0616 over the sine of 36.874. So what you're doing is you're looking at the length and the opposing angle, the length and the opposing angle, and the length and the opposing angle. So D1 is equal to sine of 129.09 times, and D2 is equal to the sine of 14.036 times, and the magic of the copy, do a copy, put it right there. That's interesting. It did not have copy, put it right there, and then put it right there. So there you go. So let's calculate those using an octave thing. So sine degree of 129.09 times 2.0616 divided by sine in degrees of 36.874 gives me the distance here, 2.66. So this will be 2.66. Pretty interesting. And I can go up and I can hit this one with a 14.036. ends up being 0.83326. Now, here, I'll just do this. Here's your, oops, forgot the point. And this distance is equal to 2.666. So now I can figure things out. I can figure out that velocity of point C is going to be, well, first I need to do the B. Velocity of B is equal to 8 from the last time, so I'm doing this, times the distance from B to the instant center, which there's B and there's your instant center. So I'm looking for that distance, which is actually the same as this distance here. It's 2.6666, and so and I'm assuming there's just a pile of sixes there. 21.333. Okay. Here's your velocity of point B. I'm so sorry. This. Okay, velocity of B is equal to 8, which is equal to omega BC times 2.6666. Boy, that was a big blunder there. But omega BC is equal to 8 divided by that big long. Well, so omega BC is 3. Now, he's basically going straight for finding this acceleration. So we'll do that. This may be split over to 2 periods. So, hey, that's okay. I'm watching the time, so we're trying not to overdo our time. Because I've got these silly meetings I got to go to. Okay, so let's look at the velocity of point C, which now omega BC times the distance from C to the instant center, which is 3 times this really tiny number, 0.83326, or 3 times 0.83326, about 2.5, roughly about 2.5. Neither one of these were what he asked for. However, both of these are needed in order to answer this question. And excuse me. So, now that we've done all this, let's go and try to answer the question that he asked us. But to get there, we had to know the omega BC. And I believe it was 3? Yeah. Now, what's interesting, here, I'm going to put the direction on it, but per se, it really doesn't need to know the direction. I'm going to tell you why. As I move everything off to the side and come back down this problem, in the standard way. Okay, so as we look at it, I see everything. I'm going to slide all this except the original drawing to the right. I'm going to solve for the velocities to verify the answers I've got. And then I'm going to go through setting this up through the accelerations. So I don't know how to do this except maybe here, I'll tell you what. I'll try to select everything I can, move it to the right, and then bring some of the pictures back. So here's what I'm doing. I'm going to select as much as I can. I move it to the right, way over here. And voila, actually all the working happened over here. And I'm left with the problem statement the way it was. So let me do the velocities first. And the reason I'm going to do the velocities, and I'm going to show, this is to double check the answers I had before. And through the process of me doing this, you're going to see something interesting. Okay, velocity B is equal to the velocity of B relative to A, plus velocity of A. Now, A and B have to be on the same length for this to actually be useful. And it so happens that they are on the same length. And, give me a second, we have the equation written like this. Now, where this, in fact, is this. Now, I'm going to slide to the right, or I'm going to write under here, and then slide it down. Okay, so now I'm going to write velocity of C is equal to velocity of C relative to B plus velocity of B, because C and B are on the same length. We can do this. What is useless to you is this. Totally useless. C and A are not on the same length. The distance between them changes. So this is not appropriate. It has to be on the same length. And here, I'll fill the rest of this out. Velocity of C is equal to omega BC cross R, this, plus velocity of B. And what I'm going to do is take this second equation and move it down, work out the first, and then attack the second. Now, how do you do this? Once you, up. Can I not move my pen? Okay, we're back. Luckily. Okay. I don't know why it does this, but it does. So, once I work this out, I can get B and put B here. So, what you do is you work through one of this. This point B is common to both lengths. That's what ties these two equations together, is the fact that this point B exists on both lengths. Now, let me take off and start working this, but in order to do this, I'm going to basically estimate, probably incorrectly, how much space I need, and I'm just going to move this down here. I'm going to work this equation out and then pick it up down here. Hopefully, that's a reasonable. However, let me take a pause here and stare at both these equations for a second. Let me bring them back together, move them a little bit to the right, and then focused on the geometry of the drawing. I'm going to basically split this away. This is my instant center approach. We're going to double check it here. And we're going to come back and say, we recognize that we need to find these two things over here. Let's see what these are. A vector originating from A, R, B, A. Originating from A and pointing to B. Man, that is pretty simple. Originating from A, pointing to B is going to be 2J. That's it. Nothing more to it. Now, a vector originating from, hang on, let me write it. Originating from B, pointing to C. And pretty simple, moves back this way, moves down, this way. That's it. Nothing more than that. So the reason I stopped is I needed those vectors throughout, so I might as well go ahead, grab them. As a matter of fact, you know what I'm going to do? I'm going to go ahead and grab this one with this one and move them down the page. Now I'm going to just work here. Okay, now we have to realize, remember, whatever it is, this is X, this is Y, and a positive rotation is this way. So therefore, I would conclude AB is equal to plus 4K. Now remember, see if I can zoom in a little bit better. This rotation comes from you taking your right hand, pointing your thumb straight at you, and rotating your fingers from X towards Y. Your thumb then points in the plus direction straight at you. Therefore, any rotation or any direction that is rotational, this is not a rotation, but it's a rotational acceleration, is positive that way. This also tells us that alpha AB is equal to minus 5K. So in other words, I turn these directions into coordinate vectors that point either straight at you or straight away from you. Now I can keep going. So I'll go back to my purple thing. Okay, velocity of B, which is equal to now IJK, and I'll grab this and stick it in here. That is 0, 0, 4. And then I'll grab this and stick it in here. And what I've got is 0, 2, 0. Now velocity of A. Hey, wait a minute. Let's stare at it. This is fixed. Therefore, it's gone. Now, I need to watch my time a little bit, so I may have to bring it to a close. I'll complete this. We'll complete this problem on Monday, but I'm going to keep going a little bit more, and we're going to drop out. And I'm taking my time in these to make sure that we see the structure. So I'm going to complete this problem in a very structured way. Okay, velocity of B will also be, okay, as a reminder, X this out, use the matrix, goes right here, 0, 4, 2, 0, minus J. Again, X this out, take this matrix, put right here, 0, 0, 4, 0, and as always, you're not going to get much here. Sorry, you're not going to get anything here. X out, take this matrix and put right here, look for the determinant of these things. And your first one, 0 minus 8I 0, 0, 0, 0. So there's your velocity of B. Is that consistent with what we've got? Okay, over here, we found the velocity B going back this way. That was the velocity that was on B. In other words, here, if you take this thing, wasn't done a scalar, was it? And guess what? Now it is. So this velocity goes in the negative x direction. Its value is 8, was 8 over here, is 8 over here. Now, didn't need that much room to solve this. So now I'm going to draw this thing back up here. And say to myself, okay, now I'm doing the second phase of this. I changed the pen, so velocity of C is equal to I, J, K. I do not know the omega BC. So the way I'm writing this is omega BC, the vector, is equal to omega BC K. So that's why you see it change from a vector to a scalar all of a sudden. It's not magical. It's that's kind of what I've been doing. So just be aware of that. Now over here you get minus 0.5, you get minus 2, you get nothing. And then guess what you get? Minus 8i. Now, I know there's no k component from this, so I'm going to shorten this a little bit. But I'm going to go ahead and say I times, take this, take this, and put it right here. 0, omega BC, minus 2 and 0, minus j. Kill that off, this off, take these two, put them down here to take the determinant of them. 0 minus 0.5, omega BC and 0. And so what do I get? Now, I have to carry this. Now, what do I get over here? Nothing, and a minus, which would be 2 omega BC I. Nothing. Minus a minus a minus becomes minus 0.5 omega BC J minus 8i equals to velocity of C. Now I'm going to stop. I'm going to focus on this, which came from this, which came from this, which came from this. I'm going to ask myself, does this look reasonable? First approach, we talked about this before, the dot product. Take this number, multiply it times that number. Add to it this number, multiply it times that number. A minus to minus on the second term right here. This gives you a plus, and it turns out that in fact this is okay. So in other words, my result is perpendicular to the r vector. Second thing, does it make physical sense on the drawing? Let's see. Let's go ahead and do a copy. We have that drawing here. We could drop it right here. Actually, let's do it a little even different. Let's do the copy. Let's put this drawing right there, which I'm not sure where it ended up. It ended up in two places. No, I am not sure what happened. Oh, this one was a copy of that one. So, here. Hello, hello. So let's look at this thing. Now, mentally, what is this in the green? What that is in the green is I am sitting on B, observing C. I am sitting on B. It is as if this is fixed to me. I am looking there. A positive rotation is this way. Therefore, this is the rotation. Therefore, from just logic, I would say the velocity must go here. It must have a positive x, a negative y. A positive x and a negative y. So logically, this component makes sense. Now, we have an extra issue. Let us now move like this. I'm going to basically, now that we've kind of logically argued that, I'm going to do a copy. I'm going to jump down here under this, and I'm going to say we've got all this. Now what do we do? Well, here's what we do. Hopefully I can do that. So here's this. However, I'm going to take this time to erase everything around here and just look at C. So if we just look at C, we got an issue here. What is our issue here? Our velocity C is either going to be going like this or like this. It doesn't matter which one you pick. Whatever you pick, let's pick the wrong one. Okay, we already know that it's going from this over here. You know what? I probably ought to go here. We already know from this it's going down. I'm going to pick it the wrong way. And so I'm going to pick it the wrong way, meaning that this velocity is going to be some VC. So this vector is going to be VC times 4/5 I, in other words, a component going that way, plus VC times 3/5 J. Now, I think what I'm going to do is stop at this point, and we're going to pick up later.